So today it's the hyperbola. And the hyperbola has these two asymptotes and a center point. And the center point is the coordinates hk. Put the formulas down underneath here later. And the hyperbola in this particular instance is a horizontal one, or as I prefer to think of it, the foci are horizontally aligned. And so it ends up being that the vertices, or each vertex of the hyperbola, the center point, and the focus points, or in plural, the foci, are all aligned on this horizontal axis. And so it's a horizontal hyperbola. And so how do we calculate the points? The coordinates for these points, for instance, this point is going to be this distance away from the center point, and in this case it's A. Actually, in both cases it's A. For both the horizontal and vertical, it's the A value. And so how would we calculate that? Since this one's horizontal, we take the original H value from my center point and subtract the value from A, and then K would stay the same, or we would, to get the right hand vertex point or vertex, I would take H and add A, comma K. And the foci are H plus C, comma K, and H minus C, comma K. This distance being C, and this distance being C from the center point to the focus point. The formula for this horizontally aligned hyperbola, so this is horizontally aligned, and I think of the horizontally aligned foci, or horizontal hyperbola. Its formula looks like this: x minus h, the quantity squared, minus y minus k, the quantity squared. The x term is over a squared. The y term is over b squared. And it is the horizontal one because this term, the x term, is the positive term. So the positive term is the x term, this guy right here. Okay? So this causes it to be horizontal. Let me highlight this minus sign again. That's different from the ellipse, and which causes it to be a hyperbola and not an ellipse. Now, how there's the relationship to the C value and the A and B value is different. So C squared is equal to A squared plus B squared. And then you'll also be asked to determine the formulas for the asymptotes. And so the formulas for the asymptote for the horizontal one is y minus k equals plus or minus b over a times x minus h. And let's actually grab that and slide it underneath this guy, so it's sort of lined up. Okay, so that's your horizontally aligned focus points, or horizontally aligned foci points, or the horizontal hyperbola. So now the vertical one. The vertical hyperbola looks like this. It also has two asymptotes. It has a center point. The coordinates for the center point are still h comma k. It also has two vertices, and it has two focus points, or pluraled foci. And the foci are the same distance from the center, this value of C, and the vertices are that same distance A from the center point, A, C, and C. And this one is the vertically aligned foci, or the vertical hyperbola. And I think vertical because all the points, those 5 critical points, share a vertical line of reflection, or they rest or reside on this vertical line of reflection. And so the relationship that C has with A and B is the same for both versions, the vertical and the horizontal. But your formula looks a little different. Your formula for the vertical, its positive term, hopefully you sorted this out before you even started drawing it, its positive term is the y term. And so I get y minus k, the quantity squared, over a squared, minus, again, this minus sign, which makes it a hyperbola rather than an ellipse, x minus h, the quantity squared, over b squared equals 1. And then the formula for the asymptotes is y minus k equals plus or minus a over b x minus h. And so this is a summary of both the vertically and horizontally aligned hyperbolas. And you can see their differences primarily in the asymptotes, the asymptote formulas, and the first term. The horizontal one, the x term is positive. The vertical one, the y term is positive, or it's on the left or the front or whatever you want to think of it, but it is the positive one. And so those are the differences. Now let's go through 3 examples. And so we'll kind of take them sort of in order. The first example I have is y minus 4, the quantity squared, over 49 minus x plus 3, the quantity square. I had to look at the screen. Over 25 equals 1. So first thing I notice, the first thing you should ask, is this vertically aligned or horizontally aligned? My y squared term is my left term or my positive term. So this is telling me that it is vertically aligned. So I'm going to have a center point. I'm going to draw my picture over here. I'm going to have, I guess I could have drawn these in. I'm going to have these asymptotes. I'm going to have the hyperbola itself with some vertices. And then I'm going to have some focus points, or plural foci. I'll try to stop doing that. And now we can do some work. So what's my h and my k? My h is -3. My k is 4. My vertices. This vertex is going to be -3. And what's my a value? My a value is 7 squared. I'm sorry, my a squared term is 49. So that's 7 squared, which makes my a value 7. So I'm going to take -3, and I'm going to take -3 from the first vertex. And since this is vertical, this distance right here is 7. And this distance is 7. So this one I'm going to take 4, and I'm going to add 7 to get this upper vertex. So 7 and 4 is 11. And to get this other vertex, I'm going to take -3 and leave it alone. I'm going to take 4, this 4 over here, and I'm going to subtract 7. So I get -3, comma, -3. To get my focus points, I'm going to have to calculate this C value and determine what it is. And it is C squared equals A squared plus B squared. That's the relationship I'm going to use. So C squared is equal to 49 plus the 25. So C squared is equal to, what, 74? So C is equal to the plus or minus the square root of 74. Since it's a distance, we disregard the negative sign, and I get square root of 74. And 74 is not divisible by 4, nor is it divisible by 8. Think 8 times 9 is 72. And so I don't think there's a way to simplify this. 24, 2, 5. Yeah, I don't believe so. So I believe square root of 74 is the most simplified version of that. I could be wrong. I'm just not pulling the calculator out and checking and whatnot. Just trying to examine the number 74. So now my focus points have the following coordinates. The x value is the same as it has been for both of these. And now the x value, the y value, I'm going to take this 4, and I'm going to add the square root of 74. So it's 4 plus the square root of 74. And 4 minus the square root of 74. And strangely enough, a little bit annoying, the software is asking you to enter decimals in one of the other problems, I think, or one of the other conics. This one they want you to enter in the exact value, so you're going to be entering the square roots. So this last part, I goofed this up a little bit. I kind of just blew through it. The first part of this question, they give you the formula and they ask for the vertices, and I just calculated it straight through. The second part of the question, they ask for the foci, the coordinates of the foci, and the third part, they actually ask for the formula for the asymptotes. So since this is a vertically aligned or vertical hyperbola, you're going to use this version of the asymptotal formula. Y minus k equals, is going to be an x minus h over here, but the coefficient is going to be plus or minus a over b. And so that gives us y minus 4 equals plus or minus, I think it was, what, 7 over 5? 7 over 5 x plus 3. And so, yeah, 7 over 3. Excuse me, 7 over 5. And so that's the correct answer. All right, so what's the next question? The next example. So the next example is a little different. So we'll go through it, and then we'll have one more after that. Y plus 5, the quantity squared, over 36 equals 1. And so here we go. So the first part, I'll try to break it down into parts. The first part's asking for the vertices. And so the first thing I'm going to ask, is this horizontal or vertical? Since it's my x term is my positive, this is horizontal. And so I'm going to put my center point here. And I'm going to draw some, well, I guess I can draw some asymptotes, right? And this is never to scale. This is just to organize my information. I'm going to have this really skinny since I drew my asymptotes pretty skinny. These are my vertices. And then I have these focal points. They're usually pretty tight in there. I'm going to put them out here so I can write the numbers, or write the coordinates. Actually, maybe I do want them tight, so I have more room. Okay. And so we want vertices on this first shot. So the vertices is going to require me to have the center point, and so my center point is -8, -5. Pause and make sure you understand where those are coming from. Since it's horizontal, my y value is staying the same, and my x values are changing. So I'm going to take my a value, which is 2 squared, and my b value, which is 6 squared. Actually, it's my b squared value and my a squared value, but I think you know what I'm saying. So my a value, this distance is 2, and this distance is 2. And so I'm going to take -8 and subtract 2 to get -10, comma, -5 for my left vertex. And my right vertex is going to be -8 plus 2, so that's going to be -6, comma, -5. And so those are the answers for part 1. Part 2 is asking for the focal points. And so the coordinates for the foci are the center value plus this value for C, or subtract the value for C, but I have to first find out what C is. So C squared, irrespective of what vertical or horizontal hyperbola, is equal to a squared plus b squared. So that means C squared is equal to 4 plus 36, which is 40. And so C squared equals plus or minus the square root of 40, which is equal to, not a negative because it's a distance, so it's going to be positive, the square root of 4 times 10, which is 4 times 2 times 5, which is 2 times the square root of 10. So that's my simplified version. And so my coordinates for instance, this right focus point is going to be -8 plus 2 times the square root of 10, comma, -5. And the left one is going to be -8 minus 2 times the square root of 10, comma, -5. I'm just shifting it to the left or shifting it to the right. And so that's the second part. And then the last part is writing out the formula for the asymptote. These are being entered in individually. Since it's horizontal, my general asymptote formula looks like this. Y minus k equals plus or minus b over a times x minus h. And so my answer is going to be y plus 5 equals plus or minus 6 over 2, which is 3, by the way. X plus 8. And so those are my 3 parts of that question. And this is the third example. So example 3 is going to be, we're going to skip this guy. So my third example is if we're sort of going backwards. And so they give you that the foci have coordinates -4, -5, and -4, -11. So notice that the y values are changing, so this is a vertically aligned, but we'll verify it when we look at the coordinates for the vertices. The vertices have coordinates -4, -7, and -4, -9. So you're given that information and you're asked to write the formula of the hyperbola in standard form. So since this one's vertical, and we'll look at this information, I'm going to have a center point for which I don't know the coordinates, but I need to find the coordinates, so I have my h and k in my standard form for the hyperbola. Then I have vertices. They look like this, right? And then I have focal points, or foci. I did it again. And so I'm going to have this information, and I'm going to use that information to find some distances. So first of all, the distance from the vertex to the center point is here, and I have this -7 and -9 as the total distance between the vertices. So -7 and -9, so there's a total distance of -2, or excuse me, total distance of 2 between those. That means my a value is 1. So a is equal to 1. Now my c value, the distances between my c values is -11 and -5, so that's a distance of 6. So that tells me my foci distance, or c, is equal to 3. My c value is equal to 3, because that's how I'm going to get 3 here, so that this has a -11, -4, and that this guy up here has -4, -5. That's just the distance of 6 units. So then I divide them by 2, and it's 3 and 3. So I'm going to use that information to find out what B is, and then also use it to find out what my center point is. So my center point is going to be 1 y value lower than this upper vertex. So my center point has the coordinates -4, 1 down, so that's going to be -8. And so it's -4, -8, halfway between -4, -9, and -4, -7? Yes. And so that's my center point. That gives me my h and k. I have my a value. I just need my b value. And c squared equals a squared plus b squared. C squared is 3 squared equals a squared, which is 1 squared plus b squared. This is 9 equals 1 plus b squared. Subtract 1 from both sides, and I get 8. And that tells me that b is equal to plus or minus the square root of 8. It's a distance again, so I disregard the negative. So I get plus square root of 8, which is which is simplified as 2 radical 2. So now the formula for my hyperbola in standard form, since it's a vertical one, I'm going to have y minus, I shouldn't say standard form yet, the general form of the standard form is y minus k squared over a squared minus x minus h, the quantity squared, over b squared equals 1. And so I'm going to get y minus the center point is that. So it's going to be y plus 8, the quantity squared, over my a value was 1. So a squared was 1, minus x minus negative 4, which is plus 4, the quantity squared, over my b squared value. And so my b value was 2 radical 2. My b squared value was 8. So I guess I really don't ever actually have to find b. I keep doing that, but anyway. And so that's the answer that I should be working with. And so that's really it for this video, other than I'm going to tack on the end here. You're going to see some GeoGebra work to help you see dynamically what's happening, but you're used to seeing that from the other two videos. All right, thanks much. Bye. So this is this guy, hey, Kevin Hopkins, made this in GeoGebra. I'm just going to show you a couple things. So unlike the ellipse, when a gets greater than b or b gets greater than a or whatever, the orientation of the ellipse changes from vertical to horizontal or horizontal to vertical, depending on what we started out with. That does not happen with the hyperbola. The nature of the hyperbola being horizontal or vertical has to do with which term is positive and which one is negative. So in other words, if it's the x term minus the y term, then it's horizontal. If it's the y term minus the x term, then it's vertical. And that's what dictates it. So what happens is when I open up A, all it does is, when I increase A, all it does is increase the distance from the center to the vertex. So as I do that, it gets wider. Happens to get skinnier as well because the B value is fixed, but we'll talk about that in a second. So now, since this is a horizontal one, this Kevin Hopkins guy, if he wants a vertical one, he actually has to construct a whole new one, I believe. There's not going to be an easy way to flip that. I guess you could create a coefficient that was a variable and just flip it, like click it from negative to positive. You'd have to change 2, I think. Yeah, I think you'd have to change 2. Any case, so as A got bigger than B, it didn't make it into vertical. So now I'm going to fix A. If I increase B, what is happening is the distance from the center to the focus is increasing. Why? Because c squared, this distance squared, is equal to this distance squared plus this b value squared. So if a squared is the same value all the time, I'm going to fix it at 1.4 squared. As I increase b, then that right-hand side of the equation, a squared plus b squared, is becoming a larger number, which means my c squared, which is equal to that, will become a larger value as well. So as I bring this increase b, the distance from the focus to the center increases. When that happens, it's stretching this out and widening my hyperbola. That's sort of related to the ratio of a and b, whether it's a over b or b over a. In this case, the horizontal one, it's b over a. So as I increase b, the slope on this asymptote increases. The slope on this asymptote decreases because it's becoming a larger negative value because the b is in the numerator. When I decrease it, it becomes flatter because the coefficients in that asymptote, which is a linear equation, that coefficient becomes smaller, that b over a, the magnitude of it. So absolute value of plus or minus b over a becomes a lesser value. So that's kind of what I wanted to show you with the dynamic thing. You can go to this website and play around with it if you want to understand it a little bit better. All right? That's it. Take care. Bye.